Today we will study geometric series. In one of the last videos, we have studied about geometric sequence. Now in this video, we will study about geometric series. If you didn't subscribe till now the channel, so subscribe it. Let's move further. What is geometric sequence? We have studied this, that the first term, when it is multiplied with some common ratio r, then we will get the second term, and then again this second term is multiplied with r and we are getting the third term, and so on. So this is an infinite geometric sequence. If we are stopping this sequence up till a certain term, then this will be a finite sequence. We are taking, for example, first three terms up till this point. Then we will say that this is a geometric sequence or geometric progression of three terms. That is this thing. So this is a geometric progression of three terms. And if we are stopping this up till this point, so then it will be a geometric progression of two terms. If we are stopping this geometric progression till four terms, so the fourth term is AR cube, then this will be a geometric progression or geometric sequence of four terms. We are stopping this over here. So this is a geometric progression or geometric sequence of four terms. So now these are finite sequences because this is a finite geometric progression or geometric sequence, because the last term is known. This is the last term. So when we are knowing the last term of the geometric progression, then the geometric progression will be a finite geometric progression. Suppose generally if we are stopping this geometric progression at suppose at nth term, this is the nth term. We have studied this in the last video of geometric progression or geometric sequence. So this is our an, and we are stopping this at this point. This is the last term. So n may be anything, 1, 2, 3, 4. So if we are putting n is equal to 7, this means the last term is a7, and over here a1 r power 7 minus 1. This is the seventh term, and the geometric progression will be of 7 terms. Now what is geometric series? When we write the geometric sequence in the sum form, instead of commas we are writing sum. That is, first term is added with the second term, and then third term, and then fourth term, and so on. So now this is an infinite geometric series, and it is represented by S infinity. And if we are making it a finite geometric series, then it will, suppose we are taking two terms and we are writing those two terms in the sum form, then this is a geometric series of two terms. And if we are writing three terms from this geometric series, then we will write S3, that is a1 plus a1r plus a1r square. So these are three terms of this geometric series. So this is a geometric series, finite geometric series of three terms. If we are writing four terms, for example up till this point, then this will be a geometric series of four terms. Generally saying, if we are taking n terms, that is we are going up till this point, and we are writing some plus plus signs between each of the two terms, then this will be a geometric series of n terms, and so on up to a1 r power n minus 1, and we will replace commas with plus signs. How this series is represented? First, how this sequence is represented? Sequence is represented as a1. What is the general term? The general term is a1 r power n minus 1. This is the general term. And for example, we are taking two terms, then n will be starting from 1 to 2. If we are taking three terms, then it will be written like this, n from 1 to 3. That is, we are taking up till this point. And if we are writing up to the four terms, then we will write over here the upper limit is 4. But how a series is represented? A series is represented as, for example, this is an infinite series. How this series will be represented? This series will be represented as S infinity is equal to, it will be represented by sigma notation, and instead of n we are taking k from 1 to infinity. And what is the general term of this series? The general term is the same, a1 r power n minus 1. This is the general term, and so on. So the general term will be written over here, but instead of n we are taking k. So this is, excuse me, this is the general term, but instead of n we are taking k. And now this whole infinite series is represented in this form as a sigma notation, and k from 1 to infinity. The upper limit is infinity and the lower limit is 1. If we put k is equal to 1, we are getting this first term, and if we are taking k is equal to 2, then we are getting this second term, and when we are putting k is equal to 3, then we are getting this third term, and so on. And we will write, for example, k is equal to 1, we are putting over here, so a1 r power 0 plus, now putting k is equal to 2, and we will put plus sign over here, k is equal to 2, then we are getting the second term, a1 r power 2 minus 1. 2 minus 1 is 1. Then when we put k is equal to 3, then 3 minus 1, that is 2, and we are getting this third term, and we are placing plus signs, so and so on. So this means this whole infinite series, geometric series, is represented in a short form like this. But if we are taking, suppose, 2 terms, 3 terms, then if we are taking just 2 terms of this series, then this will be S2, and it will be represented by k from 1 to 2 and a1 r power k minus 1. So it will stop when we are taking 2, and when we are taking 1, this will be the first term, and when we are taking 2, then that will be the second term, and we will stop over here. Now if we are taking 3 terms up till this point, then S3, it will be S3 summation k from 1 to 3 and a1 r power k minus 1. So this series of 3 terms is now this thing. So if we put k is equal to 1, k is equal to 2, k is equal to 3, and we are placing plus signs, then we are getting this series up to 3 terms, and so on. Now this is the example. This is the first term, and now what is r? R, we are dividing second term by first term and third term by second term. So this is the first term, this is the second, this is the third term. Second term by first term is equal to 18 divided by 27, 2 by 3, and third term divided by second term, and we are getting 2 by 3. The result of both division is same. This means the common ratio is 2 by 3, and this is a geometric series. Now what is the general term? The general term is a1 r power n minus 1. This means the general term is, what is a1? 27, and what is the r, value of r? 2 by 3 n minus 1. So now this is the general term. But if we simplify this general term a bit more, then 27 is written like this, and distribute this power n minus 1 on 2 and 3, and we are getting 3 power. Now bases are same, so we will write 1 base 3 and power 3, and this power will be subtracted and multiply 2 power n minus 1. So this means an is equal to 3 power 4 minus n and multiply by 2 power n minus 1. Now this series, this particular series, is written in this form: 27 plus 18 plus 12, and so on. This is an infinite geometric series, and it is written in the sigma notation as k from 1 to infinity, and the general term is this, but we will replace n with k. So 3 power 4 minus k and multiply by 2 power k minus 1, and k is from 1 to infinity. So this whole series, infinite series, geometric series, is written in a short form like this in the sigma notation. But if we are making this series as finite, for example, we are taking first three terms, 27 plus 18 plus 12, then this sigma notation will be k from 1 to 3, because we are taking 3 terms, and 3 power 4 minus k multiplied 2 power k minus 1. So now we have taken the sigma notation for 3 terms of this series. Now this is a finite geometric series of 3 terms. But if we are taking 4 terms, for example 27, then 18, then 12, and what is r? R is 2 by 3. So 2 by 3 is multiplied with this 12 to get the next term. Okay, so next term will be 8. Look at this, 12 multiplied 2 by 3. 3 4s are 12 and 4 2s are 8. So next term is 8. Now these are 8 terms and these are in addition form. So this is a series of 4 terms. This one was a series of 3 terms. Now this is a series of 4 terms. Series, what series? Series, geometric series, and finite geometric series. And in the sigma notation, this will be written as k from 1 to how much? 4. And 3 power 4 minus k multiplied 2 power k minus 1. And this finite geometric series is represented as sigma notation in a short form like this. With this I end the video, and in the next video we will be doing more examples on this subject. Okay, thank you.